Welcome to another episode in my course about microservice. Our topic for today is the API composition design pattern. When dealing with two or more microservices, it's often a problem to implement queries that join data from multiple services. For instance, we have catalog and inventory microservice. Catalog provides the API in managing the catalog models, such as product, while inventory handles the stock of a certain product. In the inventory service, product data such as code is not maintained. Now, how do we generate a list of product stock with product code and quantity? One answer is the API composition design pattern. Drawbacks and solutions. This pattern is easy to use as we are just calling multiple microservices to get the data. However, some queries can be inefficient as it might require pulling each record one by one. For example, if we have a list of 10 product stocks with different product ID, that means we have to query the catalog service to get the product code 10 times. To avoid memory problem when loading a large datasets, always implement paging. A view database can be created, so this is a solution that will contain a summary of data from other database for reporting purposes. How can we create the view database? If you are using the same database type such as PostgreSQL, then you can simply join two tables from different database, and that table can exist on another database, which is, let's say, for reporting. Next is use Apache NiFi to populate a reporting table on a database whenever the source tables from different databases are modified. For example, the database or the table for product and product stock. Next is use a messaging queue such as Apache Kafka to update multiple databases. Here we have the queue. So what happened here is whenever we update a record in one microservice, it sends that delta to a queue, which can be Apache Kafka, and that delta or that change will be consumed by another microservice, which will save or which will trigger an update to another database that contains reporting data. Again, this is how our catalog and inventory microservice architecture looks like. The API composer is residing on the Terra Warehouse gateway. Now, let's look at an example API composer class, which is the same class we have in the previous video. This is about the product stock gateway controller. How is this a composer class? It's because we have two microservices here that calls data from their respective services. The first one is about the product, so catalog service proxy that find by product ID. This one returns the product, and this one returns a collection of product stock from inventory service view or from inventory service microservice. It returns a list of product stock filtered by product ID, and then we add the product code to the product stock DTO. And again, this is the actual code. Product stock contains the product ID, and we have the product code, the serial number, and other fields. Again, the code for this project is available on GitHub, which will be available in the description section of this video. And let's stop there. Next, we will modify the load balancer project so that it will delegate the call to the API gateway and the other microservices that we have. And I think that's it. I hope I'm able to impart some knowledge that could be of help to your professional career. Please help my channel by clicking the subscribe button as well as the bell icon to receive updates when I upload the next one. Thank you for watching and hopefully I'll catch you in the next one. Goodbye!